So if you had this data, you have 10 patients. Psychiatrist 1 order them from 1 to 10 on how ill they are. Psychiatrist 2 also ranks them from 1 to 10 to see how ill they are. 10 is the worst, 1 is the best. And the question is, what's the correlation between those two? How reliable is expert rating? Because correlation in this case can be used as an estimate of how reliable their rankings are. So, what 2 columns are you going to need to add? D and D squared. I didn't put up any ties this time, so there's nothing you have to divide or break. All you do is subtract across and see if you can solve it. Alright, shall we start to walk through it? Just do the basics. So first thing you do is figure out the D column. So we've got 1, -1, -3, 3, -1, 1, 0, 1, -1, and 0. Square those, you have 1, 1, 9, 9, 1, 1, 0, 1, 1, 0. Add those up, 18, 19, 20, 21, 24. So sigma d squared equals 24.
Yeah, I squared it in.
Now, one way to avoid, certain errors, again, if you pretend this is single variable statistics right here, enter these numbers, press stat, and then just look up sigma x squared. Pretend this is an x variable. It'll square it for you and add it up, so you can double check yourself. It doesn't take very long. But for something like this, it's just as easy to do this way. So then the problem would be 1 minus 6 times 24 all over 10 cubed minus 10. So that's 10 times 10 is 100 times 1,000 minus 10 is 990. So then we'd 1 minus 6 times 24 is 144.
Yeah.
So this is going to be a fairly small number, so the correlation is going to be fairly big. What's 144 divided by 990?
115.
So 1 minus 0.15, which equals 0.85. Let's say you did this whole thing and you came down here and your answer was 1.6. What should you figure out immediately? It's not right, because it cannot be over 1 or less than -1. So that means you forgot to divide something, you forgot to square root something, you forgot to do something if your correlation coefficient is, absolute value is greater than 1. Don't forget to do this separately and then subtract it from 1 at the end. That's the single biggest error that people make. They get all the way down here and they write down, so the correlation is 0.15, and you go, you were so close. You forgot one tiny step.
If we were to do that on like an exam, or like, yeah, I guess we don't have any test in exam, would you give us like?
Oh, for things like that, I'm not my old professor, which was all or nothing. If it wasn't perfectly done, including rounding to 2 places at the end, if you were off by 1/100th, you got 0 points. If this was a 20-point problem, I'd probably give you 19 out of 20 for getting, or maybe 18 out of 20, for getting to the end and having everything except this last step.
I got so close. Like I did the things right. I just like squared the square again, so I made like 500 something, and then for some reason my head drew up 9,990 instead of 990. But I get the process.
Okay, so there's so many ways little errors can come into it. When I give you the exam, because it'll basically go in order questions from chapter 1 through chapter 7. My advice to everyone, since you have a week to do it, do the first section the first day and stop. Just do the stuff that was in chapter 1 or chapter 2, whatever it is, the first day. Then when you get to mean standard deviation stuff or whatever, do that all at once and stop. Then do the correlation problem and stop. Then do the regression problems and just do little bits at a time and go back, use your book, look up things, look up previous problems, things like that. Yeah?
Just to be sure, don't miss the 1 minus 1.15 again, 85, right?
Yes.
People like to skip that.
They just stop writing down. I was raised in an era where you showed your work. You showed every step. You wrote out every portion of the thing, and as you solved one portion, you kept bringing down the rest of it. The current generation, you guys, Most of your math teachers didn't require that. If you just write down the final answer. Or if you could do 3 or 4 steps in your head, you just did it. Or, like a lot of schools, they gave homework, but the teachers never graded it. You graded it. And gave yourself a score in the book. And then walk home. So you never got into the discipline of methodically, step by step, solving each portion individually until you get down and copy the equation at every step. You do that, you're not going to make mistakes. You try to do, I can do an awful lot in my head. Okay, you've probably seen that. I'm fairly good at calculations. I'm not my brother, but I'm still pretty good at it. I write down every step. Okay, when I'm doing these, when I put together the questions I'm going to give you, and I have to solve it first to make sure the numbers work, I'll have 2 or 3 pages per problem. I'll do every single step. So if something is off, I can go back and check where I might have made a mistake. Because if everyone in the class is getting one answer and my key says something different, I will first assume that maybe I very occasionally I will make a mistake. But I make them. But it's much easier to find where the mistake was if I've got every step written out. There will be differences in answers between what I get and you get on an exam. It'll usually have to do with rounding. So if you're off by 1/10, I don't take off points. Because you probably rounded a little bit sooner and you round things a couple times, errors start to add up. If you're off by 40, if you have a negative number when it should be a positive number, if well, then it's a different error, and then I have to go into your work. But as long as I can see what you're doing step by step, I can find where you made the mistake, I can determine how many partial points I give you. If you only give me the final answer and it is wrong, I can't give you anything. Because I can't see, did you pick the completely wrong test to do? Did you mess up so badly at the beginning? Did you not recognize a simple error? I mean, I have people giving me negative sums of squares. And one of the first things we said was, is it possible to have a sum of squared numbers that is negative? No. If they're squared, negatives are gone. So if you have a negative sum of squares, you've got a problem. So those are the types of things, if I can see the steps, I can say, oh, you did everything else right, you made one little mistake here, but from then on, you used the numbers correctly. So even though they were the wrong numbers, everything else you did logically was correct. Then I can give you a whole lot more credit than if you just wrote down a final answer, show no work, and walk away with it. So the instructions on the exam will say, show your work.